So the total cost C to operate a factory is given by the function C equals 0.5x squared plus 15x plus 5,000, where x is the number of units sold. So cost to operate is a function in terms of units sold. And if they just have C here, remember we could say C of X. Remember, just in case. At what level production, that means number of units, will the average cost per unit be minimized? If we're minimizing something, that means we're taking the derivative. Taking the derivative of what? The average cost. Well, if this is a total cost, what would the average cost be? Well, the average cost is equal to the total cost divided by number of units sold. That'd be the cost per unit. Cost per unit. All right, so we need to minimize this function. Problem is, it's in terms of two variables. It's a good thing they gave us an equation in terms of C, C in terms of X. Well, let's see, 0.5 x squared plus 15x plus 5,000 all over x, and we can use our rewriting skills, and we get 0.5x plus 15 plus 5,000 x to the negative 1 power, and we're writing this way because we've taken derivatives before, so we're setting ourselves up for success. This is the average cost. Now let's find the derivative of average cost. We're finding the critical numbers for average cost. Well, average cost derivative, 0.5x plus 15, 5,000, x negative 1, and then we get 0.5, 0 minus 5,000, x to negative 2 power over x squared. So this is the derivative of average cost. This is the function for average cost. This is the derivative of average cost. We need to set this equal to 0, find the critical numbers. 0 equals 0.5 minus 5,000 all over x squared. Subtract, multiply by x squared, divided by negative 0.5, and plus or minus square root. Now that would be plus or minus 100, but we're only taking the positive value because we're not selling negative number of items. So it looks like we have one critical number. We can test it on the number line if we want to. Now we can have 100 here. All right, but if you think about it, quadratic function divided by x, we can just plug some numbers in here also. We know we have our derivative function, plug in 0, or maybe 1, maybe 2, 5,000 divided by 1, 0.5 minus 5,000, that's a negative number. Number bigger than 100, say 200, 200 squared. All right, that's going to be less than negative a half, or that's going to be less than a half. So a half minus a number less than a half is positive. So we have decreasing, increasing. We do have our cost per unit minimized at 100. Cost per unit is minimized for 100 units. You could say x equals 100 units also.